Okay. Well, I'm ready when you guys are.
For the quiz?
Yeah.
Cool. Did anyone have any questions on the preparation?
Not really. I don't think.
Yeah.
I know. I
It's
didn't understand
just
a
like
lot of the.
What?
What were you saying?
I didn't understand some of the formulas and where they get some of their information, but so I'm just trying to figure it out.
Okay.
I didn't do all of them, but
Oh, you
The formulas.
for the
yeah, like most of them
For the
are pretty straightforward, but yeah.
yeah. It took me a while to figure out where they were getting standard deviation, but I mean, if you scroll back up before question
Yeah.
7, it has all those numbers in there. I don't know if that's
Oh yes. Okay.
maybe what.
So I just yes. That helps a lot. Like I don't understand where they got a lot of these.
Yeah. Because I was like, I don't read that. Just go to the questions.
Yeah. Exactly. So I was thinking then like, oh crap. Lots of these.
Alrighty. Oh, oops. There's so many things to like click on.
No.
Yes. Get out and ready.
Oh, okay. Sorry.
Oh, you're good.
Alrighty. Oops. Hey, I'm so confused. Oh, okay. Sorry, I'm just looking up.
Fine.
Yeah, you're just fine.
Okay, margin of error is just the second part of the equation, which is the z-score times the standard of deviation divided by square root of it.
Okay. So I got for z-score 0.126.
What did you get? The z-score? Did you say you got? What did you get? The z?
0.126.
How did you get that?
I got 1.645.
How did you?
You put it in the normal probability applet as the area, so the little thing up top.
Uh-huh.
You put in the margin or the percent.
Okay.
And then you just shade the middle, so leave the tails unshaded.
Oh. Yeah. Oops. Okay.
Okay. So yeah, just the middle. So 0.1003? Or are we getting the z?
I got 1.64.
Oh, 1.645. Okay.
Oh yeah, that's what I got.
I
And then
shaded the wrong
multiply
areas.
that.
You got 1.645?
Yeah.
Yeah.
Okay, I still got that wrong. Let's see.
Okay, so shade in the middle, and then in the area, do 0.90.
0.90. Oh, well
And
that's
then
weird.
positive z-score. So
Okay.
it's a positive one.
1.645. That's weird. I don't know why. Huh. Okay.
Okay, 15 divided by the square root of 25. Okay. Equals. Sorry, I'm just like writing everything down.
No, you're fine.
This is the first time I've kind of actually had to write stuff down.
Maybe I'll retain it more. Maybe I'll actually learn something.
Really. Maybe.
Yeah.
I probably won't, but maybe.
I don't think I did that right.
I got 16.45.
That's what I got.
Yeah.
To 3 decimal places?
Yeah, I don't know.
Oh. Wait a second.
Let's see. Ay, ay, ay. Okay.
Let's see.
Oh, actually, now that I think about it, that would make sense. Just because it's not standard deviation, so it's not like a small thing. It's like margin of error is actual numbers. And standard deviation is 50, so the margin of error for 16.45, that's just how many points, right?
Okay.
Okay.
Like
So
even
that's not the compound interval then, right?
what?
Oh, it just says. Never mind. Okay.
So would we put
Okay.
16.50? Would that?
That's what I was
Oh,
thinking.
probably. Yeah. That makes sense.
Okay.
Oh, great. Number 4, which of the following statements is true? Hang on. I don't even know.
Lovely. I don't either.
Great, these things. Okay. Oops. Here we go. Okay, so the statistics above are called point estimators because they're just one number that is used to estimate a parameter. Okay, so point estimator. Oops. Gosh, there's so many things to click on. Okay, so bar, x bar, and mu. Possibly. I'll look up the other one. Oh, an interval estimator is a range of plausible values for a parameter. So, oh, here we go. The short answer is that we will never know for sure if x bar is close to mu. The laws of probability, and then blah, 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 blah. Plausible values for a parameter based on a statistic, x bar. Does that make sense to anyone?
No. Sure.
But it does say that it's based on the statistic, and the sample statistic for the parameter is x bar for mu.
Okay.
If mu is unknown, how many, or nah, that doesn't help. Yeah, but they do have a relation with each other. But as far as if it's mu point estimator, I think it's x bar is a point estimator of mu, because I think what they do is they use the statistic x bar to estimate the parameter mu. Does that make sense?
Uh-huh.
Okay. So that's my educated guess. I don't know.
So the first one, point estimator. Or
No, X bar,
X
third.
is the point estimator of U, I mean.
Yeah, so the third one. Mm-hmm.
Okay. I think it's a good one.
Sounds good to me. More of an educated guess than I had.
Yeah.
And that doesn't make any sense to me. Oh, so frustrating.
Yeah.
Yeah, it's kind of confusing.
Anyways, all right. Number 5.
Yeah.
Okay. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation, sigma equals 113. She collects a simple random sample of size n equals 64 and computes x bar equals 526. Okay, uses information for 5 through 8. 5. What is the lower limit of this confidence interval? Alrighty, so confidence interval is the x bar plus the z or minus the z score, whatever, right? Whether it's positive or negative. Pretty sure. Oh, okay, so yeah. So to find the lower limit, we'll subtract the margin of error. So that equation we just used, we just subtract from the mean. Okay, so x bar is 526.
Mm-hmm.
To find the lower limit, we're going to subtract. And now we have to find the z-score for 95.
Which is 1.960.
Okay, 1.960
Uh-huh.
times the standard deviation 113 divided by the square root of n, which is 64. Okay. So, okay, so 526 minus 1.96. Okay, I got 498.315.
That's what I got.
Okay. Oops. And I got the margin.
You say? You got
I was
490.
just
498.315.
All right. How did you get that? Because I'm getting a really weird answer.
So since it wants the lower limit, right?
Uh-huh.
We have to do 526 subtract the z-score, which is 1.960,
Uh-huh.
divided by standard deviation, which is 113, divided by, or times the standard deviation divided by the square root
Oh,
of
you times the standard
sample
deviation.
size. You times it. I put 1.960 and then in parentheses 113 divided by square root of 64.
Okay.
So if you want, like, you just have to find the margin of error, which was the equation we just used for question 3.
Uh-huh.
So the z-score times the 113 divided by the square root of 64 in this equation.
Okay.
And then to find the lower limit, you just do the x bar, which is 526, minus that margin of error.
Okay.
And that'll give you the 498.315.
Okay. All right.
And then we add it this time, right?
Mm-hmm.
Uh-huh.
I got 553.685.
That's what I got. Yeah. Is everyone good on 5 and 6?
Yeah, I think so.
Yeah.
Okay, number 7. What would happen to the width of the confidence interval if G increased the sample size? It would decrease, correct?
Decrease.
That's just straight reading.
Oh, wait a second. What did we get on 6? What was the number?
The 553.685.
3.685?
Mm-hmm.
Okay.
Get that?
Yeah.
Okay.
All right. Okay, sorry. Number 8.
What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? It would increase, is that right?
I think.
This would widen the confidence interval in the reading.
So.
What would happen to the width? It would increase, right?
Increase, yeah.
It says right here, increasing the confidence level will lead to, or what's it say? What would happen to the confidence interval if the confidence level were increased, say, from 95 to 99%?
Okay.
And since it is going up, it's the same thing, right? It said increase.
Yeah. I think so.
Good.
Awesome. Number 9. Bright bulb light bulb company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Round up to the nearest whole number.
Okay, so we're pretty much just solving for n, right?
Yeah, I think so.
Alrighty. Confidence. Okay. Oh, I don't even need that other part. That was dumb. Okay. Gosh dang it, lead. It's breaking. Oh, this.
Okay.
Okay, so. Okay. What did you guys get? I got 64.
Oh. I got 50. Oh, wait a minute. No.
You got 64?
Oh, let's
Yeah.
see.
Okay. I must have
Dang
done one way wrong.
Me too.
Sample size.
Oh, they want a 95% confidence interval with margin of error. 50.
I got 246.
And
246?
Yeah.
I didn't even
Well,
get
I
that
don't
one.
know where that came from.
So,
Okay, let's see.
because don't you just go like the z-score times... Oh, let's see.
What?
Okay, how are you doing that now?
Yeah.
I'm trying it again.
Are you running it?
Nope, that didn't work.
Is it super hot out there from working? Yeah. Good job, babe.
2 degrees though.
It's what?
It's cooled off 2 degrees.
Nice. How long have you had it on?
For a half hour.
Oh.
But I have to run it like 4 or 5 hours a day. But
Just run it at lunch and then at night. Oh, goodness. Because I know the margin of error equals that equation. Whoops.
What?
Forgot to do something. I forgot to times the 95%, the 1.960. I forgot to put that on there. So let us try this again.
Yes, I'm trying it
I have
also.
to read this. Okay, 1.90 times. What am I doing?
Yeah, I think it's 245.866, so that'd be 246.
Wait, what?
I think
246?
it's 246. Yeah.
Wait, how are you getting that?
Okay, so the same equations that we've been doing, you know, we're going to try and solve for n, I believe it is. It's the one that's under the square root.
Uh-huh.
So you have to divide each side, because we already know what the answer is going to be. It's going to be 50.
Yeah.
So you divide each side by 1.960, and then you get 25.51, and then is equal to 40 divided by square root of n. So to get
Ooh.
a better equation, times both sides by square root of n. So then you have 400 equals 25.51 times square root of n, divided by both sides by 25.51. You get 15.68. And to get the square root out of its square root, you just square it,
Oh.
I believe.
Wait, you
That's
got
245.862.
245.862?
Yeah.
Okay,
That's
gotcha.
346.
I was thinking the z-score was part of the confidence interval and not the margin of error, so
That's
I didn't include it the first time.
Yeah.
Oh, yes.
Yeah,
So
so
hopefully that's right. I don't know.
that's what I got.
I think it is.
Okay,
I did it right this
It
time.
makes sense.
good. Yay.
Good job.
So since we have to round it, it'd just be 246.
Yeah.
Yeah.
Wow, you're so
I
lucky.
guess we could take part of it. All right. All right. Ready for 10?
Yep.
The mean salary of actuaries is mu equals $100,000, and the standard deviation of sigma equals $36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis with a level of significance alpha equals 0.05, and the alternative and the null hypothesis. You collect a simple random sample of n equals 36 women's salaries and find that x bar equals $111,000. Use this information for questions 10 through 12. Okay. Okay, so the lower limit of the 95% is 0. 0.960 minus to find the lower, right? Okay, so
Yeah.
or the, what is it? X bars. That would be 100,000. Okay, so what I'm going to do is I'm just going to find the margin of error, and then I'll just add it and
Sounds good.
subtract. Okay.
Good idea.
Okay, so.
So 1.960 times 36,730.
36,730. Yep, divided by the square of 36.
36? Okay.
Yeah, square root of 36. Was it 36,730? I cannot read my handwriting.
So you get an 11,998.466.
Yeah.
Eating.
Okay. Just write this number down.
Okay.
And then we're going to subtract that from 111,000.
Yeah, that'll be the X bar. And we have to round to the nearest whole number. So I got 99,002. Or 99,002. Yeah. Okay, I read that right.
Okay, you got what?
99,000.
And 2. So 99002.
Okay, perfect.
Okay, and then the upper limit, I got 122,000. No, is that right? Yeah, that's right.
That's what I got.
Yeah.
122,998.
Mhm.
So it'd be 122,999, right? If you have to round it.
Rounding it to the whole number.
Is it since it's 0.4? Do you round it down?
Yeah.
Probably, yeah.
Okay, so would it be 98?
Yeah.
Okay.
So I was thinking I saw somewhere that you have to always round up.
Really?
Remember. Find it.
Rounding.
Oh, sorry guys, I can't hear you. Okay.
Oh, if the answer is not a whole number, you will always round up to the next highest whole number.
So 999 then?
I think so.
If we're doing the sample size calculation.
Okay.
Huh, interesting.
Alrighty. Well, that makes it simple. 999.
But I don't know if that means for the confidence interval. It just says when doing size calculations, if the answer is not a whole number, you always round up. So would that be the same?
Sample size.
Is it a sample size calculation? I don't know.
Yeah, because look, it had 791.3 and it rounded up to 792,
Oh,
right?
yeah.
Okay.
That's
Alright,
So that's right.
12's all of the above, right?
Sounds good.
I'm pretty sure those are all requirements. I remember from reading.
I think so.
Okay.
I think so.
Think so.
I think so.
Yeah, see, simple random sample, X is normally distributed, and sigma is assumed to be known. Perfect.
Awesome.
Okay. I'm still worried about this number 11 one. 'Cause-
About rounding?
yeah. Because I know with like number 9, it says round up to the nearest whole number. Because it's a sample size. Does it?
Yeah, see, it does it rounds up.
112.
Does it pertain to the confidence interval also?
Oh, because it does say sample size.
Okay. Let's look at it again. Okay. Yeah, look, it says we always round up in, or, oh, never mind, that's still sample size. Okay, confidence interval. I would assume so.
Want some rice with me?
Thinking.
Chicken. What could it have been?
We're gonna care or something. The wings take forever.
You gonna pick that up?
I don't know.
Well, because it isn't a sample size, so would we round down then?
I'm thinking
then
so.
get it wrong.
That's what I'm wondering.
Because if we get it
Sorry.
wrong, we can't
No,
say it wasn't a
because of that.
sample.
So
Yeah, it doesn't say round up
997, right?
No, 990.
Yeah, 998.
Oh, okay, good. So if I already rounded up or not? Okay, sounds good to me.
Okay.
Okay. Are we good on all of those?
I think so.
I think so.
Alrighty. Submit.
Whoa!
Yeah. I'm excited.
Nice. It's our
Good
first
work.
one, right?
Yeah,
Yeah.
that's
And I
awesome.
still don't understand anything.
I know,
That's okay.
right?
It's okay.
What's in the car?
That's awesome.
Nice. Good work.